I'll be explaining stoichiometry mass to mass, chapter 12.1. Using a balanced chemical equation is very important when doing stoichiometry problems because it tells you what amount of reactants are needed and how much product is expected to be formed. In daily life, people like accountants keep track of profit, expenditures, and income through keeping good track of what is happening to the money. Chemists use stoichiometry to keep track of what happens to the reactants and products in a chemical reaction by using ratios of moles. Stoichiometry is defined as calculations of quantities within chemical reactions. When converting grams of something to grams of another chemical compound in the balanced equation, it should always look like this. You start with grams, and then moles over grams, and moles over moles, which is the mole ratio, and then grams over moles. This is the first problem. It says, calculate the number of grams of NH3 produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. So you want to start out with the given, which is the 5.40 grams of hydrogen. And then now you want to get grams of H2 on the bottom. That way these can cancel out. And now here you want to find the actual mass of hydrogen. So you look on here, the periodic table of elements, and the atomic mass. Over here it would be about 1.01 when rounded to the hundreds place. But because it's H2, you have to multiply 1.01 by 2, which would be 2.02 grams of H2. Now we want 1 mole of H2 up here because we need to do the moles over moles, the mole ratio next. That way we can get to the answer. We need to do the mole ratio first because we can't go from grams of one thing to the grams of a whole different compound. They have to be converted to moles using the mole ratio before then being converted to grams of the substance we're looking for, which in this case is NH3. And so now to move on to the mole ratio, you need moles down here, moles of H2, because these canceled out, and now these need to cancel out. And the mole ratio of H2, you look for H2 up here in the balanced chemical equation, you find H2, and then you find 3. So this would be 3 moles of H2. And then now we need to find the mole ratio for NH3. And remember, we want grams of NH3 as our answer. And so now we need the moles of NH3. We look over here, and then it's 2. The number here is 2, which means this is 2 moles of NH3. Now to get our answer, we have to get 1 mole of NH3 down here so that these can cancel out. And then we can, and these already did cancel out. And now we need the grams of NH3, NH3. And so now to do this, we have to bring back the periodic table again. And then nitrogen is over here. It's about 14 grams. And now you have to add that to the grams of hydrogen. This is H3, and we know hydrogen over here is 1.01 times 3 because of the 3 here. And so it's about 17.0 grams. And now we just have to multiply everything on the top by everything on the bottom. And when we do that, the answer comes out to 30.35 grams of NH3. Now to our second problem. So it's slightly more complicated. So it says if you have 66.6 grams of NH3, how many grams of F2 are required for complete reaction? And the given here is 66.6 grams of NH3. We always start out with what's the grams of what's given. And now we need to find the grams of F2. We do the same thing while keeping this in mind. And we have to get grams of NH3 on the bottom, which would be, after we look on our periodic table, it would be 17.03 grams. And now we want 1 mole of NH3 up here. That way these can cancel and this can cancel out with the mole ratio. Now with the mole ratio, we have to find NH3 in the balanced equation, NH3 right here, and it's 2, so this would be 2 moles of NH3. And now we're looking for F2, so we have to find the moles of F2. If you go over here, it's 5, so it would be 5 moles of F2. These cancel out, and for the last step, just like in the last problem, you have to find the grams of F2. Be moles up here, so cancel out. Now we need the grams of F2. This way we can get our answer. And going over here, about 19 times 2 because of the 2 here, and then it would be about 38 grams of F2. And then if you multiply everything on the top and divide by the bottom, it would come out to 371.52 grams of F2.